let's construct models from data points. So, in 1980, the average cost of a pack of cigarettes was $1. In 2000, the average cost was $3 per pack. Calculate and interpret the slope. All right, so to calculate our slope, we first need to kind of think about ordered pairs. And because I feel like we're going to be constructing a linear model, we're going to need a y-intercept. And recall that with y-intercepts, you have to have an x value of 0. So I always start with my oldest year. So 1980 is the oldest year, so I'm going to say, let's let x equal 0 for 1980. So that gives me the ordered pair 0, 1, because at the beginning, cigarettes were $1. Now, if x is 0 for 1980, think about the year 2000. Well, that's 20 years later, so the x value would be 20. So the other ordered pair is 23, because in 2000, the cost was $3 a pack. Now I have two ordered pairs, so I can find my slope. Here's my x values, here's my y values. And remember, slope is the change in y over the change in x. So if I find the change in my y values by subtracting, then I can subtract my x's on the bottom, and I get 2 over 20, which simplifies to 0.1. Now think about this in terms of money. So this is my slope, but if I write that as a fraction, 0.1 over 1, because you can make anything a fraction by putting it over 1. So the top number represents money, and the bottom number represents years since 1980. So what this means is that cigarettes have increased, and I know they've increased because my slope is positive. So they've increased 10 cents per year since 1980. Right? So this is the 10 cents. This is the year since 1980, and it's an increase because it's positive. So I know that my slope is 0.1. So let's construct a linear model. Well, here we go. If my x value here is 0, then my y-intercept is 1. So y equals slope times x plus my y-intercept. And that would be our linear model after 1980. So use this, y equals 0.1x plus 1, to estimate a cost of a pack of cigarettes today. So today we are in the year 2018. Now remember, x was 0 for 1980. So if we're talking 2018, how many years later is that? 38. So x would have a value of 38. So if we take that and plug it in, y equals 0.1 times 38 plus 1. 0.1 times 38 is 3.8 plus 1. Oops, I'm not sure what that was. But our y value would be roughly $4.80. So we could estimate that a pack of cigarettes today is going to be $4.80. And I have no idea if that's accurate or not, because I have not bought a pack of cigarettes ever. There you go. Okay, the next problem. The population of a city was 4,800 in the year 1900, but had dropped to just 450 by 2005. Calculate and interpret the slope. So again, we start with our oldest year, 1900, and we say let x equal 0 for 1900. So that ordered pair would be 0, 4,800. Now in 2005, well, that's 105 years later. So x would have a value of 105, right? We just subtract. If you subtract these two, that's how you can find that. So that ordered pair would be 105, and there are 450 people left. Okay, so that gives me two ordered pairs. And again, here's x's, here's y's. So first I want to find my change in y. Y value minus y value over corresponding x value minus x value. So I get negative 4350 over 105. Now you can leave it like that if you want, or I'm going to go ahead and just turn that into a decimal. So this is my slope, negative 4143. Interpretation, well, if I would put that over 1, the top number is the y values. Y represents population. So the population decreased by 41 people per year since 1900. I know it's per year because the bottom number is a 1, and I started in 1900. So it's per year in 1900. And recall, This is moving forward. Since this is my x value of 0, my y-intercept is 4,800. So I've got a slope of 4143 and a y-intercept of 4,800. So when I want to write my model, I've got my slope of negative 4143 times x plus my y-intercept of 4,800. So remember, you just plug your slope in here, your y-intercept goes here, x and y remain x and y. Use that model, that y equals negative 4143x plus 4,800, to predict the population in the year 2015. Okay, well, let's remember, x was 0 in 1900. So if I'm talking about 2015, how many years later is that? That's 115 years later. So my x value is 115. So y equals negative 4143 times 115 plus 4,800. I multiply first, and that gives me negative 4,764.45. I add 4,800, and I end up with a y value about 3555. I'm going to go ahead and round that to 36 because we're talking about people. So in 2015, the population of this town would be roughly 36. And remember, we're dropping at 41 people per year. So can this trend continue indefinitely? No. In 2016, we are out of people. Think about it. In 2015, you ended up with 36 people. If you're losing 41 people a year, and so out of 36, if 41 leave, you don't have any people left. So no, it can't work. Eventually that town will die.